Hello friends, welcome to EC Academy. In this lecture, let us understand R2R ladder digital to analog converter. A digital to analog converter converts the binary input into equivalent voltage and current, which means it will convert the digital data into analog form. Figure shows the R2R ladder digital to analog converter. R2R ladder digital to analog converter is used to overcome the disadvantage of weighted digital to analog converter. The weighted digital to analog converter had a limited number of inputs as well as the output is not accurate. This figure shows the 4-bit digital to analog converter. Since the resistor values are 10 kilo ohm as well as 20 kilo ohm, which means we are having the resistor value R as well as 2 times R. That's why it is known as R2R, and these resistors are connected in the form of a ladder. That's why it is known as R2R ladder digital to analog converter. In this circuit, switches D0, D1, D2 and D3 are connected to reference voltage, or they are connected to the ground depending upon the input binary value. These switches represents binary input bits. If input is 1, then the switch is connected to reference voltage, and if the input bit is 0, then the switch is connected to ground. So for example, if the input bit is 1001, then switch D0 is connected to reference voltage, D1 and D2 connected to ground, and D3 is also connected to reference voltage, so that we can get the combination as 1001. Likewise, for different combinations of input, these switches will switch to either reference voltage or ground. So this network will convert the binary inputs 0000 to 111 and 1. Since there are 4 switches, so we will have 16 combinations of the input from 0000 to 1111. So for these 16 inputs, we will be having 16 unique output voltages. So there are 16 combinations of input. So for these 16 combinations of input, we will get 16 unique output voltages or output levels. Here switch D0 represents the least significant bit, and switch D3 represents the most significant bit. To get the output voltage, first the binary input are converted to decimal equivalent values. So to obtain the output voltage, first the binary input are converted to decimal equivalent values. So we can use the formula binary input B in is equal to D0 into 2 to the power of 0 plus D1 into 2 to the power of 1 plus D2 into 2 to the power of 2 plus D3 into 2 to the power of 3. Then we can find the output voltage using the formula V out is equal to minus B in divided by 2 to the power of n into 2 reference voltage. So we can find the output voltage by taking the formula minus of binary input divided by 2 to the power of n multiplied with 2 times reference voltage. Here capital N represents the number of inputs. Since we are taking 4 inputs, we can take capital N as 4. Let us take an example. If D0 is equal to 1, D1 is equal to 0, D2 is equal to 0, and D3 is equal to 1, and V reference is equal to plus 5 volt. Now this binary input has to be converted into equivalent analog output. For that, first step is to find the binary input value. So let us use the formula and find binary input value. So we can say binary input is equal to 1 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 3. So we will get B in value is equal to 9. Then we can find output voltage V out, that can be given as minus of 9 divided by 2 to the power of 4 multiplied with 2 into 5 volt. So if we solve this, we will get output voltage as minus 5.625 volts. So this is the output voltage value for input 1001. This is about R2R ladder digital to analog converter. Hope you have understood the topic. Thank you.